Hello, my name is Ian Clark, and I'm going to tell you about our recent enhancements to IPSLA functionality with Aruba-CX 10.16 First up, we will look at the new IPSLA rolling average history data feature. As you are probably aware, we have had the ability to use NAE to record IPSLA histories and calculate averages for a variety of IPSLA types for quite some time. However, getting this set up was not a trivial task, and we'd have to go outside the IPSLA environment to record the long-term results and calculate those statistics. As of 10.16.1006, we now have the ability to record results for all the different IPSLA probe types from within the IPSLA configuration themselves, making it a far simpler task and without requiring the use of NAE, meaning that we can better use those NAE resources for higher value activities. In addition to the result recording features, we also record the maximum and minimum RTTs for a probe, as well as a rolling average of that historical data, allowing us to see a trending of results over that period of time. We can also tune the probes with timeout values, just in case there is an environment that needs to deal with responses that are beyond our default timeout of 5 seconds. Results are recorded into the CX database, and reporting of the IPSLA history results can be retrieved through CLI or through API calls, which includes not just the results within the historical reporting period, but also the calculated statistics. All current CX platforms, except for CX 6000, 6100, and 4100i, support this feature. Let's cover some deeper details on this new feature. It covers all the IPSLA types that the CX supports, namely ICMP and UDP Echo, HTTP, HTTPS, TCP Connect, UDP Jitter, and UDP Jitter VoIP. We can record a maximum of up to 7200 seconds or 2 hours for an IPSLA, and that the minimum history interval is at least twice the probe interval value, as we need at least 2 probes to call it a history instead of just a result. When using ICMP Echo or UDP Echo, it is recommended to set the timeout to be less than the probe interval, just so we don't have the IPSLA waiting for multiple probe responses for the same test. We can run a maximum of 8 concurrent IPSLA history sessions at once, and changes to the history interval configuration on an IPSLA cannot be made while the test is active. And while not specific to rolling average history data feature, it is also good practice to remember the following for all IPSLAs. Like all IPSLA tests, once started, they will continue to run permanently. Both IPv4 and IPv6 probe targets are valid. IPSLA targets using DNS will only resolve on the first returned IP, and NTP must be set if using UDP Jitter VoIP. On the subject of UDP Jitter VoIP, and indeed UDP Jitter IPSLAs, if either one of these is used, a specific COP policy must be set to ensure accurate reporting of results. Here's an example of the output of the history results for an ICMP Echo IPSLA. Note that it shows the history interval, which is how long we are recording the rolling probe results for. The results section itself shows successes and failures, as well as calculated statistics from the rolling history interval data in the CX database. Similarly, if we look at the IPSLA probe type, in a different case, this being HTTP, we not only get the specific probe statistics, but also the TCP statistics too. And now moving on to our other IPSLA enhancement, use of route or resource tracking to change static routes without using NAE. As with the IPSLA rolling average history data feature, we've been able to make changes to static routes based on monitoring targets in Aruba-CX using NAE, particularly with the connection monitor script, for quite some time. While it did what we needed to do, setup was also complex and would consume NAE resources within a switch. With 10.16.1006, we are now able to define tracking objects which are based on IPSLA results. A change in state of a tracking object can trigger a change in static route, including a default static route. Object tracking is tied to IPSLAs and the success or failure of those probe results. Multiple tracked objects can be combined into Boolean lists, allowing for complex object tracking logic. The designation of a tracked object is very straightforward, and as we are now doing this as part of the standard CX configuration, we do not have to use NAE for this purpose. It is a simple three-step process to get this functionality working. Firstly, define the IPSLA and start it. Secondly, define the tracked object that uses the IPSLA. And finally, put the static routes in, one for use when the tracked object is reporting as up, and another for when it is down. All current CX platforms except for CX 6000, 6100, 4100i and 6300L support this feature. Let's get into the details. Not only can we look at next hops as tracking objects, we can target any ICMP echo target across the network. For example, we might have a network path to a server in the data center available via an SD-WAN link and another via an MPLS link. If we use the server as a tracked object, we can affect static route changes within the switch independent of any other WAN routing functionality. We can also use UDP echo IPSLAs, provided that the target is another Aruba CX or AOS-S series switch with the appropriate UDP echo responder set up. As part of the tracking object construct, we've also delay, up delay and down delay timers, which allow for situations where we might have a link flap or we need to delay a change in network path. We can track up to 64 objects simultaneously on CX 6300 and above platforms, or 50 if we're on the 6200 family or CX 5420 chassis switch. As previously mentioned, objects can be placed into Boolean and or Boolean OR lists to create complex tracking capabilities. A list is also counted as a tracking object in addition to the objects it is constructed of. Static routes can be IPv4 or IPv6, and both the routes and tracking objects can be assigned to different VRFs, noting the platform object trapping limits are per system and not per VRF. Like any IPSLA construct, once an IPSLA test is run, it will run permanently. Any DNS entries that are used to look up an object will only be using the first resolved IP address, and we can use both IPv4 and IPv6 targets. For those of us that like to go checking in the switch event logs, we won't find any route change information there, but we will see changes to tracking object state. We should all be familiar by now about how to show an IPSLA and its result, now inclusive of rolling average historical results, as well as how to show a static route. We can also bring up the state of tracked objects, both individually or all the objects that have been defined. Let's cover off those three steps again. Step 1, create the IPSLA. In this case, we're creating an ICMP echo test, as that only requires setup in a single CX switch. Remember that we can only use ICMP echo or UDP echo for tracking object purposes. Step 2, create the tracked object and tie it to the IPSLA. We can verify it as running with the show command. And step 3, put the static routes in, including one that is tracking the object. Note that while we've only got one tracked object being used here, we can actually have multiple tracked objects with different distances for the same route, so we can preference multiple paths depending on tracked object availability. So what happens when we get a change in tracked object state? When our configuration is put to the test by network conditions, specifically when an IPSLA fails and a tracked object state changes to down, we get a change in static route. In this case, we've had the ICMP echo IPSLA report that the target is unavailable, resulting in a change in state to the tracked object. After the delay timers are processed, the static route changes, in this case to a different interface. Remember that we won't see the static route change in the event log, only the change in tracked object state. If we wanted to do something a little bit special, we can combine both of these new features. In this case, we can see the impacts to the rolling average history data that is recorded on the IPSLA after a change in static route to a tracked object. We will see this in the demo. Today I'm going to show you a demonstration of our recent enhancements to IPSLA functionality with Aruba CX, namely rolling average history data recording for IPSLAs, and also the ability to change static routes using object tracking without having to use NAE. Now, before we go into the demonstration environment, I'm going to show you how the environment is connected together. We have hosts A and B connected to their own layer 3 switches as gateways. These switches are connected with 2 available layer 3 paths, one slow path with some high latency and the other low latency fast path. We have a static route from host B to host A to go preferentially via the fast path. We have IPSLAs with history data recording enabled and tracking objects set up on CX switch B, with the target being host A. To initiate the route change, we're going to disable the fast path link on switch A, which should result in a tracking object status change in switch B, which will trigger the route change to go via the slow path. As we have IPSLA history data recording enabled, we should be able to see the effects of this change reporting within the average probe round trip time values. Now let's look at the demo environment. I have already run a trace route between hosts A and host B to verify that the clients are indeed using the fast path. Let's have a look at the running configuration on CX switch B. The first part to note is that the IPSLAs have been set up and are running. There are 5 in operation at this time, all with history data recording capability enabled, and the length of history that we want to record in seconds, and this can be up to 7200 seconds or 2 hours per IPSLA. 3 of these IPSLAs have been set up for the CX to record history data between switch B and host A, and the other 2 are set up for the switch to monitor the availability of switch A over the 2 different paths. We will use these last 2 as part of tracking object status, noting that only ICMP echo or UDP echo probes can be used for this purpose. The second part of the configuration shows the setup of the tracking objects themselves. I have set up 2 objects to track the IPSLA service availability, labelled Server Fastlink and Server Slow Link, which are tied to the IPSLAs for their respective paths. I have also set up 2 object lists, labelled Combo Track List and Combo Track List OR, which have Boolean values of and OR respectively, to show how we can combine objects into a list, which can also be used for route changes. The last part of the configuration is where we have set up the static routes between switch B across the network to host A. I have a static route which specifies the fast path link, which relies on the state of a tracking object, and we have another static route with a specified distance, which is the route used if the tracking object is down, in this case the slow path link. Something to note is that different CX platforms have different IPSLA capacities. I can check to see how this one is going by using a show capacities status, and I'm just going to limit that to just the IPSLA data just to see what is available, and we can see that there are 5 IPSLA sessions currently configured out of a possible 500, and 5 IPSLA history sessions enabled out of a possible 8. Take a look at the tracking objects. See that we have all 4 tracking objects showing that they are up, and the last time they had a state change. As the tracking object we are using for the static route change is Server Fastlink, and it has a corresponding IPSLA session of over my Fastlink, it is also reporting as up. Now let's look at one of the IPSLAs between switch B and host A, as well as last set of results. The results as well. So note that it is showing us all the cumulative test data and the last test result as well. As we now have history results, let's see what the differences are. Note that the results here are only for the history interval and not since the probe was started. Right now, the RTT for the probes are showing 0, as the fast path latency is under 1 millisecond. As we have relatively low values for both the probe interval and the history interval, we should see changes to the RTT average in a short amount of time after the route change. A last check of the routing table shows us that the route to the 23 network, where host A is via interface 112, which is on the fast path. And I'm also going to clear the event log so we can see the effects of the changes of the tracking objects as they occur. I will set up a continuous ping between the two hosts so we can see the effects of the route change in real time. Now, to enact the route change, I'm going to disable the fast path interface on switch A. We can immediately see a drop of pings between the hosts while we wait for the timers to expire on both the IPSLA and the tracking object down delay. And there we have connectivity again, albeit with a much higher ping, meaning that the slow path is now in use. If we check the route now on switch B, we can see that the route has indeed changed to the slow path next hop address. Looking at the event log, we can also see that there was a tracking object status change, but there was also no entry for a route change. Let's take a look at those tracking objects now. Note that server fast link is showing down and the time since the last change is recent. Additionally, the Boolean ANDList object is showing down, while the Boolean ORList object is showing up due to tracking the same IPSLAs. Let's look at the IPSLA history of our ICMP Echo IPSLA again. Note here that the average RTT values have increased as the probes are now going over the slow path, and they are rolling into the defined history interval timeframe. Let's make the fast path link available again on switch A and let the routes change back. And now we wait for the object tracking to kick in again and process the link up timers. And now we can see that they're using the fast path again with reduced latencies. Looking at the event log on the CX switch shows that there has been a change in object state again for both server fastlink and the Boolean ANDList to up. A quick check of our routing table again shows that the original object tracked static route is now back in use, and that concludes this demonstration. We hope you find these new features useful. Happy IPSLAing!